Hi guys! So here we are today. It's just me today. Adam's not with me because it's Monday and he does his proper job on Monday. There's a van just outside, and before you say anything, I didn't do that wiring, so yeah. It's just wiring, just kept in place. That's going to be replaced at some point. Yeah, we've got to do, today's job is an EICR for this property. As usual, they've got it all nicely decorated, as you can see. A couple of nice new lights put up. Well, I say new, I don't think they're new. But yeah, as you can see, they've had everything fitted, fit kitchen and everything. And they want a ticket. Well, let's see if we can give them a ticket or not. Who knows? This is the first time I've been involved with this, so I've had a quick look around. You can see there's a few new electrical bits and pieces. Yeah, as I say, I've not been involved in this so far, so it's going to be one of them DIY Dave things, isn't it? So basement's down here. Mind your head. Already whacked me head on that. We've got a rewirable DB. Actually, say again, it's not rewirable. It's got the old flip modules in. It's the same board, but they've changed it for resettable MCBs rather than the rewirables. But yeah, I still call it rewirable. Gas bonding over here. Gas is over here. Bonding's there. We'll check that. Make sure it's in place. It's a 10mm. Probably change that over because that's falling off. Water bond is plastic, so we don't need to worry about that. That's the main stopcock. System we've got here, so we'll stick the light on. So we've got it's one of them TNCS mixtures. It's got the PME label on it, so we're going to treat it as a TNCS for the sake of this report. So the first thing we're going to do is we're going to do a mixture of a few different things at the same time. We're going to walk around, have a bit of acquaint ourselves with the property, do a functionality test on some of the sockets and lights, make sure they're all working before we do any work, point out any observations. Just see one here, just got a regular screw in one of these sockets, so we change that socket out. Have a look why it's got a screw in it. Yeah, just getting acquainted with the property, pointing out any observations that we might find along the way. And also we're going to be doing a wander lead test at the same time. So just like this, we've got a wander lead, we've got one end in there. I'll show you that in a minute. So one end is attached to our earth bar, MET, and the other end is going to be on the end of this probe. And all we do is just stick it into the CPCs, make sure we're getting a good reading, 0.46, so we know we've got a good reading there. And we're going to keep doing that all around. Again here, same time we'll check our bonding. Yeah, perfect. What I like to do with these as well is I will take that bonding off just to make sure that that is definitely connected to the MET, because otherwise you might be getting parallel earth paths through the pipe. So let's do that now. I'm going to be changing this out anyway because it just needs changing, you can see. It's a bit old. Let's see if we've got a reading here, just on this. So yeah, perfect. It says 000, but we know that's pretty good. As you can see, we've taken that socket off, and you can see it's got a drywall back box on it. So we're not going to be able to get a regular screw in now, I reckon. So we'll have to change the back box and the socket. Yeah, having a little inspection, make sure it's all okay, no scorch marks. Yeah, all in the right terminals. What we're going to do as well, we're going to take these downlights off. You can see it says IP23. There's no problem with ingress protection in here because it's a basement. So let's have a look whether they're fire rated. What we're doing when we do this as well is we're having a look to see if it's got an earth on it. Sometimes, well, a lot of the time, you get the earths cut back. This had the earth run through it, it looks like. Good cable. But yeah, they're not fire rated. Let's have a look up here. Yeah, that's just straight into the floorboards upstairs, so I'm gonna see to that because it's not fire rated. And upstairs is a living area. Leave that down for now, and I'll make an observation in my notebook. Basement downlights not fire rated, times 6. So when we price it out later on, we know how many we need. Pull off light switch. As you can see, to be fair, I'm quite surprised by this so far. All the cables are flagged up brown, which is good because they're switch lines. They've put the CPC in there, in the sleeving. You don't need CPC, and it doesn't have a terminal, so that's fine as it is. Pretty good so far, and it's new colours, so that's telling me now, if it's new colours, it's possibly had some sort of rewire, could be quite recent. And there goes my phone. So it's very important to check things like faceplates are earthed. Yeah, so anything metal really. I say anything metal within reason. Check these. Have we not got a reading on? Oh, yes, we have. So I know they're good earthed. It's just such a quick way of doing it as well. If you don't get a reading, then go inside on one of these screws. You should get a reading. And I'm surprised I'm not. So that's the isolator for it. Oh, as you see there on the sign there, it says double insulated. Could be why we're not getting a reading. Okay. 1.38. 1.24. Whilst we're checking fuses. Oh yeah, the old 13 amp fuse. Not suitable because this will be 130 watts. Let's have a look. This will be about 130 watts. So we need to change that fuse out. As usual, kitchen fitter or whoever, just they haven't bothered changing the fuse. It's just got the regular 13 amp fuse in it. So we'll leave that there as a reminder. And we'll write it on our observations. Change extractor fuse. When I'm looking at properties, I go in a clockwise way, so I'll go around this way and then all the way around there. So I know where I've been. Wine cooler. Yeah, good earth. Got some lights in here. These might be double insulated. Yeah. These should be earthed. It's easier if you have the sound on, because then you don't have to look at the readings. Faceplate. It's one of them screwless types. So let's get in the back. Get him off. Yeah, it's fine. Right, I started this at 9:30. Some cowboys will be out of it by 10. Let's see how long it takes. I reckon it's going to be about 3 o'clock by the time I get done. they've got fuse connection units up in them. See what they're powering. Another thing we do, go around with a Q-Tech tester, make sure that the wiring's correct. These are not to be relied on, but it's to give us an indication at the start. This also tells us that they're all working. Because we will do the end-to-ends and the crossover test, the figure of 8 test. So we've got a socket in here. That's to the macerator, or whatever you want to call them. So one's going to be for one side, one's going to be for the other. So that's one on the right does that. That's just straight on the ring, that one. That one's got a fuse on it. No need to worry about checking the fuse because it's on plugged up anyway. So anything you plug in there should be on the correct rated fuse anyway. Observation we've found is we've seen got a cracked socket there just in between the switches. Also, can I say, if any of you's got these type of things in your sockets, take them out now, because you can put them in upside down like this and you can leave exposed terminals. The earth pin could snap off, leaving them open. These have been safety approved by British standards. Don't need any additional equipment to make it safe. Having these makes it unsafe. I'm going to take them out and you can see that's completely cracked across anyway, where the camera picks up. As you can see there's some cracks in the sockets. This one over here has got some cracks on the bottom. I always mark them up with big X so I can see from a mile off what they are. Cables here exposed, they're satellite TV sort of thing. No problem. So open up the accessories. Metal faceplate. This is why we do it. You've got the CPC protecting plastic box, but no protection on the metal faceplate. Which is always great, isn't it? This is why we do it. So I'll change that over. It's only a quick 2-minute job and job done then. Right, so what we're doing is checking these light fittings. They're not earthed. 12 volts, okay, but they're not fire rated. They're not fire rated. Looking at where that light fitting was, it is at about 217. So let's check the on-site guide and see what that says. If you look at the position of it, it is directly over the edge of the bath. So let's see what the on-site guide says. Look in the on-site guide. So in the on-site guide, we need to look at this one here, okay, because we've got a bath. Everything up to 2.25 meters is zone 1. So zone 1, let's see what type of IP rating we need to have. Come across to page 94. Zone 1, IPX4. IPX5 if water jets. So we've got a shower right there. This shower can almost reach that, so we have to regard that as having water jets. Okay. IPX5 with water jets, so that's what we need. So you need 25 volts AC, which is fine because we had 12 volts lights, but it still doesn't comply to the IP rating. IP rating of these, I doubt if it'll say it on there, but I would imagine that they're about IP23, something like that. You can see, you can get, if you was to squirt a water jet straight up, you can get straight into that. So, not got the correct IP rating for that, for the location. another thing we're going to put in our observations. And we have 1, 2, 3, 4, 5. We have times 5. What I'll do as well is I'll measure the cutout so we can get a replacement for it. That's 90, but if you see the depth, there's not a lot of depth. So it's 60 depth. Don't know what we're going to find for that. It's going to be interesting. Now I'm not sure if you're like me, but I have a problem when it comes to remembering the exact heights, exact IP ratings and ZSs and all sorts of figures. I cannot remember them. I just have a problem with it. It's okay to be like that, and that's why we've got the on-site guide. If we need to check that shower height and the IP ratings, we just look. And it's okay not knowing everything. That's fine. As long as you know where you're going to find the right answer, and you're going to find it in the on-site guide. If not, then you may need to ring up your technical team for your CPS provider, mine being NAPIT. And they've helped me a few times in the past. Yeah, they've been quite good. What we've got here is we've got a fuse connection unit, which is protecting the tail rail behind it. Let's have a look what fuse. Usually 13 amp. You watch. Oh, we've got 5 amp. Let's see if that 5 amp is the right type of fuse. Let's do a little calculation, shall we? So how we work out whether a fuse is the right type or right size is we do the PIV. PIV. We know the voltage is 230. Okay, we don't know the amps. We're going to try and find what the power is in watts. Let's have a look on here. You might not be able to see it, but it says 300 watts. Just there, you might not be able to pick it up, but it's right there. 300 watts. What we do, that's your watts, that's your voltage, and that's your amps. Okay, so it's 300 watts. What we do is we do 300 divided by 230 because you've got a line between that and that. So we do 300 divided by 230 is equal to A. 300 divided by 230 equals 1.3 amps. So that's what we put in here. So what we need is we need the next fuse up from 1.3 amps. It's got a 5 in there at the moment, but I know that we can get a 3 amp. So we'll stick a 3 amp fuse in and that'll be perfect for it. So we're going to have a look at the shower. Whilst we're here, have a look for any burning. No burning. Making sure that we've got a good seal around the top. That's fine. This is fine. It doesn't have to be really sealed because that's the bottom. Checking this cable size, they look like 10 mils to me, and how powerful it is. So 8.5 kilowatts there. We'll make a note of that and do our cable calcs and make sure that 10 mil cable is enough. Now I know that 10 mil cable was more than enough for that. And also, whilst we're here, I know that on the consumer unit, as you've seen just now, there's no RCD protection. I'm not sure when this was put in. I'm sure it would have been changed at some point where the installer must have thought it needs an RCD. I will be changing the board anyway, but if I didn't, I would definitely recommend 100% to get an RCD fitted for the shower, at least, because you've got water and electric, and obviously it doesn't mix. You're going to put someone in the water. If it's got a fault, then who knows what could happen. But at least if you've got RCD, it will trip before. If there's no RCD, it might trip, but it won't be until you're using it. Whilst we're on the shower, I'm going to check my R2 reading. 0.11. Now just doing our tests again. There's no earth continuity here. Check it here. So we know that the test is working. There's no earth continuity here. We do have limitations on our inspections to say that if we're going to damage anything around, any decor, then we have the right not to move it. But because there's no earth there and because it's a metal faceplate, I'm going to take that off, and might cause some damage, might not. Because that's pretty much attached to the wall, I'm going to try my Stanley knife down it. So let's have a look, see if we've got a CPC attached. Oh no, we've got the CPC protecting the plastic back box, the pattress. Lovely. Rubbish, isn't it? Such a simple thing, right? Just putting the CPC onto there. I mean, this is how you know it's a DIY guy done it. Fly lead back on. Oh look, got earth continuity now. Light working, light off. That's all they worry about. Light on, light off. They don't care whether it's safe or not. Right, look in here. You can see the socket there, trunking going round, and then trunking going along into the wall somewhere. So I'm going to pull them off, see if one's not spurred off the other, and then you've got double spur on it. So we've whipped off the covers. Let's have a look in the back. Yeah, we're in the right terminals. There's a bit of copper showing on that line, so I might push that back and terminate it or something. You can see the spur is coming through into the trunking. Follows it round. And it pops out just here. Now we can see there's only one spur, so that's fine. This is again why we check it, just to make sure we're complying with regs. Because some of you might not know, to learn this is a good thing to know. On a ring, you can only have one spur coming from a ring. If you want any more, it needs to be fused down to 13 amps. So you know, if I want you to put another one further on than this, as long as it's fused down to 13 amps, then it's fine, because it's not going to overload. It's not going to get more than 13 amps. The trunking just goes all the way along. I think that's just for decorative effect. I don't know why, because it looks rubbish. Yeah, because I thought maybe it might go downstairs or something, but no, as it usually does. That's good. Nice little cosy upstairs bedroom, 2 lights, one skylight, 2 sockets. Sockets test okay. Now we're at the end of the radial here for the lighting circuit, so I'm going to test the R2 here. 0.64, perfect. Because this is at the end of the house, the top of the house, we know this is the furthest point from the consumer unit. So because this is at the top of the house, we're happy that this is the end of the radial for the lighting circuit. There's only one lighting circuit throughout the whole house. You know, it's just the way it was made. So that's where you test the R2. You can either do just an R2 or you can do an R1 on plus R2. But it's a lot easier, just run around with one lead, do everything at once. Do all your R2s, all your bonding, and checking your faceplates and everything. Quite a cosy little room, I like this room. I'm not sure about them stairs, but quite steep it looks like. But, you know, I quite like them. But again, that's not my problem. You know, whether it complies to building regs, nothing to do with me. What we're using is electroform, and I've tethered it to my phone. The signal is rubbish. This is a problem with electroform. I spoke to them about it, but they're not going to change anything. Because as you can see, DBs are always in the basement where you've got no signal at all. Rubbish, isn't it? What I had to do is put my phone top of the stairs where it can get signal, and then bring the Wi-Fi signal down to here where I can use my electroform. What we're doing is we're going through our different things. PFC we'll do in a minute. What we're doing is we're filling out all the bits and pieces that we need before we start testing. Supply protected devices 13612, which is your main fuse over there on the left, just behind that wood. It's type 2, and that's the short circuit capacity. It gives us 33 kiliohms. Rated current is 8 amps, it says on the label. Just have to take that as a given. Means of earthing, distributor's facility. The main switch on this consumer unit, and it's on there. It says BSEN 5486. It's a 2-pole switch, but that doesn't really make that much difference because we're changing the consumer unit over anyway. Conductor materials copper, and they're 25mm towels. As you can see, you might not be able to see it, they're 25. You can tell the difference after a while between 25 and 16s. So that's all that. Oh, the main switch is rated at 60 amps. Even though it's got an 80 amp main fuse in it, it's only rated to 60 amp for the breaker, for the main switch. As I say, we're changing it anyway. Earthing conductor 16mm. Yeah, and we'll check the continuity. Main protective bonding is copper, and we know that is in 10mm. Water, there's no water bond because I'll put additional notes because it's plastic ink on. I'll write that here. Update it. Gas, we know, and that's a 10mm. Gas bond location is in basement. And that's it, that's all we need for that. For the rest of these, we just do NA. I don't like to leave them blank because then it shows that I've looked at it. That's then all done. Location of main switch in the basement. Update that. Now we come to our inspection schedule, and this is a tick and pass. Pass or fail, C1, C2, C3, or further investigation. I've already got a template. This is my template, and most of these are already pass, because I know that that's usually the right answer, but I still do go through it, as you will see. So external condition of intake equipment, visual inspection only. Service cable pass, service head. Let's have a look at these, okay? Service cable coming in. A little bit of leaking tar there. It's all dry. Not in the best condition, but it's, you know, pretty good. It's a pass. Service head. Now take a look at this. It is not attached at all. So I'm going to ring the DNO, get them to come out and take a look at that, reattach it, and what they'll do at the same time, from experience I know they'll change this over for the type with an isolator in, which would be good when we do our consumer unit change. So let's do that now, give them a chance to come and change that over. Let's actually see how long it takes for them to come over. So the DNO is Western Power. I'm going to ring 105. Let's see how long it takes for them to come out. 105. Let's give them a ring. So a good idea to have before you make the phone call is get the customer's details, the landlord, phone number, telephone number, and their address. I've got it all ready on my electric form anyway, because they're going to ask you for that. Yeah, the postcode is NN2 6DD. Yeah, my name's Dean Griffin. So I'm doing an EICR inspection, and the service head is not attached to the wall or anything, it's just loose. So just need someone to come out and just reattach it. It's the old type of service head as well, so you might want to change it over at the same time. No, nothing at all, it's just, there's nothing at all, it's just loose completely. Yeah, that's it. All day today, or Wednesday is the next day I'm here. Yeah, okay, thank you. Bye. So there you go, 3 minutes is all it takes to call the DNO to get them to come out. Who knows when they'll come out? It is now 12:15. I'm going to carry on with the EICR and just await the knock at the door. The good thing about this laptop is you've got keyboard and you can use it as a tablet. So if you need to write anything in there, whatever, you can type it quite easily there. You can use a mouse with it. You've got the pad there. Or if you want, if you're just doing the inspection schedule inspections, you just flip it around. You can use it as a tablet. You just go, literally just go like tap, 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 and go. Much easier. It's brilliant. I love it. What we're doing now is we're going to carry out a ZS test. So we pulled the main conductor out. If you look, that goes all the way back to the MET. It was just screwed in up there, and just literally pulled it out. You should be able to just literally put it straight back up and straight in the hole, hopefully. On looking at this, we can see that it's had some of its cores cut off, so that is an observation we're going to put down, but we're going to replace this anyway because we're going to put in a new consumer unit. So we'll replace the towers and everything. We connect one end to the main earth coming into the board, and we put the probe onto the line coming in. Try and do this with, just 2 hands is not easy. And we have a ZE of 0.07, which is perfect. We'll take them off. First thing we do is put the main earth straight back in case of any faults. We'll make a note of that ZE. With a ZE, I always write it down in the book because guarantee you'll get home and your electrical will have gone down. So we're going to do 2 tests for our prospective fault current. First one is going to be from our incoming neutral to our incoming line, and that measures at 1.7 kiloamps. We remember that, and we check the prospective earth fault current. 1.7 is what we got in the other one, and prospective earth fault current of 2.56 kiloamps. Don't know if you see that. So that will be our highest reading, and that will be our prospective fault current. Make a note of that first. PFC 2.56 kiloamps. You only need to do that once here. And then what we do is we check our protective devices. These are rated at 3000 amps or 3 kiloamps. You see there? We are changing these out, so it's going to be 6 kiloamps for the RCBOs. So that is well under where it should be. Next thing to do is test our rings. I will add as well, we have completed safe isolation before this. Before anyone says anything. Because this is so tightly patched now, I'm going to mark these up. 1, in case we lose where we are. I hate these boards, they're so tight to get anything out. Something I've just seen. Okay, so I've just pulled out the line conductors for that ring, and that is, I think that's the kitchen ring. You can see the CPC at the back. I'm not sure whether that's been cut or what, but it's not connected. What we do now is we do our end to ends, continuity of conductors, which is R1 to R1 and RN to RN, and then R2 to R2. What we will do though is none of the leads, because we was using the one lead before. 0.55, R1 of 0.55 ohms, R2 is 0.52 ohms. Good. So as you can see there, we've got an R1 of 0.55. So what we did is we take it at 0.55. So 0.55, and we times it by 1.67. 0.55 times 1.67 equals 0.92. That's what our R2 should be. 0.92. Okay, now let's find out what the actual R2 is. So R2, so this one, and we have loose crocodile clips, and we have 0.55. So that's, you know, that's pretty good. It's under what it should be, 0.55. At least we've got continuity on all of them. Next thing we do is a crossover. So we do, first we'll do little r1 plus little r2, rn, sorry, equals, over 4, equals 0.55 plus 0.52. Can you see that? So 0.55 plus 0.52, divide that by 4 is equal to 1.07 divided by 4 is equal to 1.07 divided by, you see at the bottom right, 4 is equal to 0.27. That's what we want at our sockets. Right, so we just had DNO out. We've just had a look at this and they've said they can't repair it just like that. Need a joint-in team to come out. So it's now about 12:30, so that's quite quick for them really. Right, now we're doing the R1, Rn at the sockets. Some people use these, but how do you know if you're measuring between R1 and R2 or Rn? How do you know what one? That's why I like to use the old-fashioned method. Then I know it's definitely measuring between R1 and Rn. So let's check this. It should be 0.27. See what we get. 0.48. So we'll go in and out a couple of times. .37, a couple of times or so. Flicking the switch a couple of times. .41, let's try this socket. .95. Okay, let's come back to that one. Try this one. .44. See, these sockets are quite stiff, getting it in and out. 0.61. .53, 52. Maybe need to take some of these off just to check that the terminals are okay and tight enough. 0.51. We're getting all about the same sort of results really. Also, whilst doing this, we're checking the polarity. We're making sure that the R1 is in the switch line, because we've got no reading there. Switch it on, get a reading. So that's telling me that one of the cables, either the R1 or the RN, are in the switch line. And the next test we'll do, R1, R2, will tell us the same thing. Now unplug this, because we're going to do insulation resistance tests next. 0.41. Let's check these sockets under here. Sockets there. No reading. That's because it's on Spur, is it? Yeah, a bit higher because it's on a Spur. Okay, so this one's not giving us a reading. No, there's no reading there, so that might be on the household circuit. It's a bit strange, isn't it? No, it's because it's on Spur again, dickhead. Oh yeah, 0.45, 0.44. All about the same sort of readings really. I've had this before, and I've spoken to Napit about it, and they're fine. As long as your ZS's are fine, then they're okay. What we'll do though is I'll check a couple of these in here. Yeah, and they're not on the circuit. So we're happy that everything in there has been tested so far on the R1, R2. So we've done our R1, RN, make sure that the sockets come out okay in the end. Now we change over in the board for R1, R2, and we change over our leads here, R1 and R2. Okay, switch them on, 0.57. Right, so DNO's just been out. They've just come in here and they've secured this back to the wall. I thought they would change it, but no, it's just a case of securing it onto the wall. That's all they've done, is solid, you know. MET is pretty solid now. They've replaced the fuse, but it says 100 amp, but it's actually an 80 amp in there, because they've told me. They said it was 80 amps, so at least we know for our documentation we've got a 80 amp fuse in there. So I'll label this up once I've finished. Next test to do, it's probably one of the most important tests, is insulation resistance test. And this will tell us if we've got any problems with the circuit and whether or not we can put an RCBO board on it. So that's what we want to do, is put an RCD on it, RCD, RCBO. So we go between each of the conductors. Put it onto insulation resistance, and I know that there's a couple of things connected to it, so I'm only going to test at 250, like things like the fridge and things like that. You can't get to the sockets. I'll try finding the sockets, but can't. Eee, not good. So we've got a short between line and neutral. Thinking about it, there's an obvious reason why it's saying this is short. Short between line and earth. And short. So all of them have got a short, which is great, isn't it? What I'll try and do So this puts us back now. Now we're not going to have a chance to get back here to fault find for a while. So yeah, you've got shorts everywhere. Not great. Yeah, the customer wants, so it's Monday now. Customer wants to let this out week today. Always get your EICR done before you've done anything else, because it's not just a certificate, because you need to find out if the installation is safe. If it's not safe, then we need to fix it and make it safe. So let's try this one. Yeah. So there's a fault somewhere on this kitchen circuit. So what we do with that is we'll put it down as an FI, and we need to come back and take a look going forward. Now, I did plan to come and change that board on Wednesday. Now we can't change it until we found the fault. Otherwise, if we put an RCD on it, it's going to be tripping out everywhere. One thing I won't say is that RCD is more sensitive, because that makes me sound like a kitchen fitter. Who gives a who cares? Having a good day, having a good day. Monday night is not pub night, because Monday night is not pub night. I don't know. So we've done all the testing. There's only one fault. Well, I say one fault. One major fault, which is the kitchen circuit has got a dead short between all conductors, so we need to get to the bottom of that. I found this a couple of times. The conductors have been snipped back because they don't fit into the terminals. This is a shower circuit, so nothing important, so we don't need that much cable on it. Luckily it is a 10mm, so, and the shower is not as strong, not as powerful as it needs to be. Yeah, cut back, and also on the bonding conductor there, don't know if you can see that, but bonding conductor's been cut, and so has the so has the main earth, and also I'm not sure what conductor that is because we've only got gas. Goes into the wall somewhere. Oh, it goes onto water, but it's not required. Why is it landlords always do the electrical certificate last? Why? They've got all nice flooring down, look, you can see all nice floors, same floor all throughout the house. Change a few of the lights, painted it all up, looks pretty, but what if this needed a rewire now? There's no way back from it. You'd have to rewire it and you'd have to cause so much damage. If there's any landlords out there that are requiring an electrical certificate, get the electrical test done first, because you ain't going to be happy if I come back and say, oh, it needs a rewire. All they're after is a little bit of paper at the end of the day so that they can rent it out. And this box looks like it's an addition. So now I have to find a consumer unit that will fit in that tiny little space. I mean, seriously, really. Does anyone else get frustrated about landlords? I'm sure we don't all get frustrated. It's so annoying. So I've just taken a quick initial look round at the kitchen circuit, just a quick one, see if we can find the fault quickly. It's not in the best condition. You can tell it's had some sort of rewiring done recently. It's in, you know, they're not too bad. I mean, look, whoever's done that, they've left the screw there, snapped off. Mixture of colours. So on this bit here, look, there's no care taken. They've obviously damaged the insulation while screwing back, and you can see bare copper on the line and on a neutral. You see all the black stuff, and that must have made a nice little bang. And here's a screw. Let's see if we can find a screw. Look. Knocks half the screw out and all. See that? Yeah, knocked half the screw out and all. So whoever's done this has energised it without testing it, and it is, you know, not the best, to be honest with you. Yeah, no good. Over here, got conductors that have just come out as soon as I pulled it off. That just popped out, and that's for the extractor fan. Yeah. So you can see it's all got new colours. So I reckon it's had some sort of rewire. Newish type of kitchen. Look, not even fixed side on. It's just no care taken. Just get a handyman to wire it up. Get some stupid electrician to sign it off, eh? Because yeah, that's what we're going to do, innit? Now we're going to test the ZS at the lighting circuit. Let's just check to see if it's working. Yep, that's working. Remove the lamp. And I'll switch it back on. Put in the Q-Tech adapter for the bayonet fitting. Remove the rose cover, and with these we don't know what one is going to be the live one, so we'll try it on either one of them. Yep, we've got 240 volts there. Let's see what the ZS is. 1.58 ohms. Good ZS. I'll remove them and then disconnect the power. Power's all disconnected. You can do his back up. Just make a note of what that one. 1.58 ohms.